Target 1. Differentiate between speed, velocity, and acceleration.
Stopping by, I'm Virgil Ricks, and this is 2-Minute Classroom. Today we're talking about motion. Specifically, we're talking about speed, velocity, and acceleration. And let's clear up a few things right off the bat. First of all, speed and velocity are different, and acceleration is much more than just speeding up. Speed is the rate at which something changes its position. It's represented as distance over time. Miles per hour, kilometers per hour, meters per second, these are all examples of the units for speed. So if you're driving in your car at 72 miles per hour, then that's your speed. In fact, it's your instantaneous speed, or your speed in that exact moment. If you get to the end of your trip and realize that it took you 2 hours to drive 120 miles, then your overall speed was 60 miles per hour. And this is also known as your average speed. Velocity is a lot like speed, except for one important difference. It's a vector, which means it has a direction attached to it. So while your speed may have been 72 miles per hour, your velocity was 72 miles per hour east, or 72 miles per hour towards the beach. There just has to be some direction attached to the speed to make it a velocity. With that knowledge in hand, you're now ready to understand acceleration, which is simply the rate at which velocity changes. It's represented as distance per time, or distance per time squared. For example, meters per second squared are common units for acceleration. Anytime you change your velocity, you are accelerating. That can be speeding up or slowing down, which is also known as negative acceleration. But direction is also a component of velocity. So when you change your direction, even if your speed doesn't change, you are accelerating. Does that blow your mind? All right, let's recap. Speed is the rate at which something moves, distance over time. Velocity is speed with a direction, so distance over time with a specific direction. And acceleration, the king of them all, is distance over time squared, or the rate at which velocity changes. So whether you're speeding up, slowing down, or changing directions, you're changing your velocity and thus accelerating. Science is so cool. I hope you enjoyed this video. Feel free to throw any comments below, whether it be questions, criticisms, or just idle chit-chat. I'd love to hear it. Don't forget to watch and share my other videos, and I'll catch you next time.
Review Target 2. Calculate average speed using distance and time measurements.
Speed and acceleration are physics concepts that we encounter every day, and an understanding of these concepts is crucial to most areas of physics. We think of speed as something we have when moving, and this forms the basis of speed's definition. Speed can be defined as the rate of change of distance. What exactly does that mean? Well, it means that an object's speed is a measure of how long it takes in terms of time for it to travel a given distance. From this, we get the following equation. Speed equals distance divided by time. The standard units of distance is meters, and time is seconds. Because of this, speed is measured in distance per time. For example, meters per second, or kilometers per hour. Let's look at an example. A car travelled 100 kilometers in 2 hours. What was its speed? So 100 divided by 2 equals 50 kilometers per hour. Now you try. A sprinter runs 100 meters in 12.5 seconds. Pause the video while you work out her speed. Did you get 8 meters per second? And another one. A jet can travel at 350 meters per second. How far will it travel at this speed in 30 seconds? Pause and have a think. Well, it travels 350 meters in 1 second. So in 30 seconds, it will travel 30 times 350, which equals 10,500 meters. So how far will it travel in 3 minutes? Pause and have a think. Well, 3 minutes is 3 times 60, or 180 seconds. So the distance it will travel is 180 times 350, which equals 63,000 meters, or 63 kilometers. In the same way that speed is the rate of change of distance, acceleration is the rate of change of speed. This means that the acceleration of an object is a measure of how much its speed changes over a given period of time. To calculate acceleration, we use the following equation. Acceleration is equal to change in velocity divided by time. Let's try an example. The velocity of a bus increased from 0 to 18 meters per second in 6 seconds. Calculate its acceleration. So acceleration equals final velocity minus initial velocity over time. Another example. A hungry cheetah saw a gazelle and decided to chase it. The cheetah was walking at 5 meters per second and accelerated to 20 meters per second in 5 seconds. What was its acceleration? Pause the video while you work it out. The sign in front of an object's acceleration indicates whether the object's speed is increasing or decreasing. If an airplane's acceleration is negative 40 meters per second squared, its speed is decreasing. The gradient of a line on a speed time graph represents acceleration. If the gradient is positive or goes up, the object has a positive acceleration. If the gradient goes down, the object has a negative acceleration or deceleration. What's the acceleration of this object between points A and B? The change in speed is 25 minus 5, which equals 20. The change in time is 6 minus 2, which equals 4. So the acceleration is 20 meters per second over 4 seconds, which equals 5 meters per second. Is the acceleration large, small, or zero in these time graphs? And is it positive or negative? Pause the video while you think. So that's how speed and acceleration are related and can be calculated.
Review target 3. Measure and graph changes in motion. Motion is the process of changing place or position. A reference point is a stationary point used to determine the position of an object. A reference point is needed to determine whether an object is in motion or not. For example, reference points could be parked cars, trees, buildings, or landforms. On distance time graphs, the distance is plotted on the y-axis. Time is plotted on the x-axis. The steeper the slope of the line on the graph, the faster the object is moving. Constant speed equals a straight line slanted upward. Acceleration is denoted by a curved line. No motion is a flat horizontal line. The line will never slant downward because total distance cannot be subtracted. Speed time graphs have the speed plotted on the y-axis. Time is plotted on the x-axis. The steeper the slope of the line, the faster the object is accelerating. Steeper slope equals faster acceleration. Constant speed is denoted on a speed time graph as a flat horizontal line. Acceleration is a straight line up or down, and no motion would be a flat horizontal line at 0. The line will slope upward when speeding up and downward when slowing down. So you made it to the end. Since it's day 2, what is today's exit task? Well, identify what tools, there are 3 of them, that you would need to calculate the speed of a toy car and what formula you would use. Tell your teacher the complete answer, and she'll give you one to keep.